Hold your breath for a few seconds. Feel that pressure building in your chest, that subtle urge to breathe. That feeling isn't oxygen running out. It's carbon dioxide rising in your blood, and your brain is extremely sensitive to it. The moment CO2 increases, your brainstem pushes you to inhale. Your body is designed to survive. Now imagine something very different. Your heart stops, one beat, and then nothing. This is second zero. When the heart stops, what doctors call cardiac arrest, blood pressure drops to zero almost instantly. There is no slow fade, no dramatic warning. Blood simply stops moving. Within seconds, blood flow to the brain ceases. Your brain cannot store oxygen. It cannot store glucose. It depends entirely on continuous circulation. When that flow stops, neurons immediately begin experiencing ischemia. At second 2, your brain detects the absence of blood flow. The neurons in your cerebral cortex, the same original neurons that have been with you since birth, the ones holding every memory you've ever made, they begin firing in a last, desperate burst of activity. Scientists call this a surging electrical wave. Some researchers believe this is what near-death experiences are made of. At second 4, your body's cells begin consuming their last oxygen reserves. Every cell has a tiny emergency supply, but they burn through it fast. At second 6, your muscles receive no new ATP, the energy currency your body runs on. Without it, the sodium-potassium pumps in every cell membrane begin to fail. And this is the beginning of what will eventually become rigor mortis, post-mortem rigidity, though that won't be visible for hours yet. At second 10, carbon dioxide begins accumulating in your blood. Under normal circumstances, this is what tells your brain to breathe. Your brain stem fires the breathing reflex, but there is no response. The signal goes nowhere. At second 15, your skin begins to change. Without blood pressure, the tiny capillaries near the surface stop carrying color to your face. The warmth that has been radiating from your skin since birth begins to dissipate for the first time. At second 20, something remarkable happens inside your neurons. The dying cells release a wave of glutamate, a neurotransmitter, flooding the synapses in a cascade that travels across the cortex like a slow electrical storm. Your brain is generating more electrical activity at this moment than it normally does. This is the most controversial finding in modern neuroscience. Your brain may be more alive in the first 20 seconds after your heart stops than it is right now, reading this. At second 30, the cells in your retina, the light-sensitive cells at the back of your eyes, begin to lose function. Vision, if there was any, fades. The world your eye lens has been focusing on since birth goes dark for the last time. At second 40, your gut bacteria, the trillions of microorganisms that have been living inside you, influencing your mood, your immunity, your digestion, they are still completely alive. They will remain alive for hours. In fact, they will outlive you by days. The ecosystem inside you continues without you. At second 50, body temperature begins its slow decline toward the ambient temperature of the room. Scientists call this rigor mortis, coldness of death. Your body will cool at roughly 1 degree per hour until it matches its environment. The warmth that made you feel alive to anyone who touched you is escaping. At second 60, your brain's electrical activity reaches its final peak, a last surge, and then begins its irreversible decline. The neurons that held your personality, your memories, your ability to love, reason, and recognize faces, they begin a process of cellular death that cannot be undone. But here is what most people never learn. Biological death and clinical death are not the same moment. Clinical death, the stopping of the heart, is what happened at second 0. The biological death, the actual death of your cells, takes much longer. Some cells in your body will still be alive an hour from now. Some will be alive tomorrow, which means the boundary between life and death is not a line. It's a gray zone that science is only beginning to understand. And in that gray zone, something extraordinary is happening. Because your gut bacteria are still alive, they reorganize. Your cells release their contents into surrounding tissue, beginning a chemical process that will eventually return every atom of you to the soil to the water, to the air. You don't disappear. You transform. The carbon atoms that built your neurons, the ones that held your memories, will become part of plants, animals, and other humans. The iron in your blood will return to the earth it came from. The calcium in the bones that have been with you your entire life will become part of the cycle that has been running for 4 billion years. Death is not the end of your biology. It is a change of address. And the most remarkable thing about the 60 seconds we just walked through together is this. Shaped by nearly 4 billion years of evolution, your body knew exactly what to do. Every chemical shift, every electrical silence, every final cascade. Even in death, your biology follows the same physical laws that built, sustained, and carried you through every moment of your life. You are nature, beautifully organized. And when that organization ends, nothing is wasted, nothing disappears, it simply changes form. If this changed how you think about your own body, share it with someone who values understanding over myth. And if you want to explore your biology at this level, clearly, accurately, and without exaggeration, subscribe. Because what your body does every single day while you are alive is even more incredible than this. Thanks for watching.